Hello and welcome to the Machine Learning Podcast, the podcast about going from idea to delivery with machine learning. Your host is Tobias Macey, and today I'm interviewing Josh Tobin about the state of industry best practices for designing and building ML models and the work that he's doing at Gantry to help support teams who are taking that journey. So Josh, can you start by introducing yourself?
Hi, I'm Josh Tobin. I'm co-founder and CEO of a machine learning tooling and infrastructure startup called Gantry. My background is in machine learning research. I was a research scientist at OpenAI for a few years in the early days, working on deep learning and robotics. Did a PhD at Berkeley doing similar things, and I'm really excited to be here.
And do you remember how you first got started in machine learning?
Yeah, I do. I actually was a grad student at Berkeley in applied math, and was trying to figure out what exactly I was going to apply math to. And so I was taking a bunch of classes in different departments and stumbled into an incredible class that I was wholly unprepared for on machine learning applied to robotics, but just pretty quickly fell in love with it and saw the potential for this technology to have a huge impact and for robotics to have a huge impact as well. And so that's it was all downhill from there, I guess.
And so the topic at hand is around the practice of modeling and what that really means in the current ML ecosystem and climate. And before we get too far down the road, I'm wondering if you can just start by giving what your sense of a so-called traditional process for building a model looks like and some of the forces that helped to shape those so-called best practices at the time that they were established.
Yeah, absolutely. So when I learned how to do machine learning in school, the process that I learned was, someone gives you a data set that you're supposed to work on, and they tell you this is the metric that you need to optimize on that data set. And then your job as a machine learning practitioner is to make that metric go up or make it go down. And machine learning as a field evolved to be really, really good at that process of taking a data set and a metric and optimizing it super well to get to the best possible outcome for that combination. And I think in industry, in the early days of machine learning adoption, it largely followed the same pattern. I think, Kaggle was a big driver of that, right? Where, sort of Kaggle reproduces that pattern of, assuming you have a fixed data set and a fixed metric. But I see that pretty quickly changing in the companies that we work with.
In terms of that kind of fixed metric and a fixed data set, what are some of the aspects of the current climate around data and machine learning and the ways that it's being applied that are starting to unravel some of those assumptions and push teams into new and different practices from what they learned as they were first coming into the space of machine learning?
Yeah, absolutely. I think the biggest thing is just what machine learning teams are being tasked to do. So, in academia, again, your goal is to beat a benchmark and write a paper, right? And if you are able to make your metric go below a certain number, then you get a NeurIPS paper and you get a PhD and you get to go work at Google and make $1 million. And in the early days of machine learning getting applied in most companies, like let's call it like the 2010 to 2020 era, outside of the largest and most successful tech companies, the machine learning teams were kind of tasked with applying modeling in a similar way, often in an R&D function or sometimes in an analytics function, where your job is to produce an answer once, and maybe that answer is used to do something strategic, like decide where to build the next McDonald's, or decide which leads your sales team should spend most of their time on. But that answer was rarely being applied in kind of like a real-time setting in front of actual end users. So as machine learning kind of moves into the 2020s, I see machine learning teams increasingly getting tasked with solving a different problem, which is, rather than trying to produce the right answer once, they're being tasked with actually building real products that are out in the world interacting with the end users of the company, whether that's their actual customers, their actual users, or internal end users. And that difference has pretty profound implication because end users don't have like the data that end users interact with is the data that end users produce when they interact with the model is not static. End users' behavior tends to change all the time, and the world changes around them. And so this assumption that we make in machine learning academia or machine learning as an analytics function that it's okay to make static assumptions about the data that we work with doesn't really hold true in this sort of new practice of building products with ML.
And there are a couple of things that I'm interested in digging into from what you were talking about. One that I'll add a note for, and maybe we'll come back to it, is that topic of real-time data, which has been gaining a
Yeah.
lot of ground in the data engineering space as well. And I've talked about it in a bunch in my other show, the Data Engineering Podcast. And I'm just curious, maybe we'll circle back to it, whether you see the adoption of real-time data being driven by machine learning teams to be able to incorporate that into their models, or the driving force of real-time machine learning being the fact that there is availability of that data now, because for a long
Mm-hmm.
time streaming was again kind of the realm of the elite tech companies and everybody else just wished they were doing it.
Yeah.
And then the other piece that I'm interested in digging into is on that question of machine learning kind of as an analytics function versus machine learning being the product. And I think that might be the more interesting angle to go down right now, and kind of what you see as being some of the pivotal forces that have moved us from the idea of, static analytics to predictive analytics to prescriptive analytics to now machine learning being the actual product that people are interacting with versus just a kind of sidecar function.
Yeah, sounds good. What's most interesting for me to dig into there?
I guess just what you see as being some of the factors that have enabled that as a consideration and have pushed people to move out of that state of machine learning is just there to give me answers to questions that I have as a business owner, versus I actually want machine learning to be the core front and center element of what I'm offering to my customers.
Yeah, absolutely. So one factor is data availability. So as organizations mature their underlying data infrastructure, I think they go through a maturity curve where, early on in that process, if, data is completely spread out in different silos in the organization and data access is limited, data quality is poor, it's really difficult to build machine learning systems on top of that. But as companies move through that data maturity curve, and start to centralize data and have better data access, better data quality, better data governance, then that reduces the barrier to teams trying to build stuff with that data. And one of the more interesting things that they can build with it is tends to be machine learning applications. The other factor that's driving it, a second factor I think that's driving it is the a reduced barrier to adoption of machine learning as a technology. So, when I first started doing machine learning, if you wanted to be on the cutting edge, like if you wanted to be building state of the art machine learning systems, it was an exercise in pain tolerance, I would say. I remember spending a lot of time setting up a GPU machine under my desk and making sure I always had the latest CUDA drivers installed, and downloading these somewhat questionable, very difficult to use frameworks for building deep learning systems like Cafe and Theano back in the day. Now, if you want to access state of the art in machine learning, it's just an API call away. So state of the art is getting easier and easier to use. More and more people know enough of the basics in order to be able to use it. So I taught a production machine learning class at Berkeley a couple years back, and I was asking one of the undergrad students, what fraction of Berkeley CS undergrads these days take at least one machine learning class, and his answer was, yeah, I mean, it seems like it's probably at least 70%, right? So the next generation of software engineers has at least the fundamental skill set to do this. And the algorithms and the frameworks are converging. So the second factor that's driving this, in addition to data availability, is just like lowering the barrier to entry to try this technology. And then the third is like rapidly expanding capabilities, right? So, GPT-3 and, but even going beyond that, like state of the art models in other domains are becoming more and more capable. And so the types of tasks that you can apply them to are wider and wider. And I'm seeing, businesses that otherwise would be probably years away from adopting machine learning where the technology was 4 or 5 years ago, that are experimenting with putting it into their products much earlier in their company life cycle than they otherwise would have.
And as people are moving into this realm now of deep learning being probably the default way that people are thinking about building their machine learning systems, and the general availability of the tooling to be able to make use of it and the improved sophistication of the underlying data capabilities, what are some of the practices and lessons that are still necessary and useful in this modern age of modeling that people maybe are starting to fall out of the habit of doing, and that they should be reminded of as they are kind of exploring the new and evolving frontier of what machine learning and model building looks like?
Yeah, absolutely. I have a bunch of thoughts on that, but I think maybe it'd be productive first to break down. I think it's actually productive to think about three different paradigms for doing machine learning. So the first paradigm is like you can think of it as like ML 1.0, right? And that's traditional machine learning. It's building regression models. It's building tree-based models. Basically, your scikit-learn toolkit, and that's usually applying it to tabular data. It's usually pretty bespoke to the actual like business application that you're doing. It's highly reliant on the specifics of your problem domain, and a lot of the work involved in it is feature engineering, because you have to really understand your data and your problem area to make the algorithms work well. By designing the features that will allow them to solve the prediction problem that you need them to solve. Then in starting in around 2012, like deep learning emerged as a second paradigm. Deep learning makes a lot of things easier, but also makes some things harder. The things that it makes easier are that it's more standardized in the sense that typically it operates on unstructured data, text, images, things like that, and because of that, the effort involved in needing to kind of tell the algorithm really, really specifically, these are the features that you need to look at in order to solve this problem, is reduced. Oftentimes these models take a pretty standard set of inputs, just some text or some images or what have you. So that's the thing that's a lot easier about deep learning than like ML 1.0. The thing that's harder is that deep learning is typically more resource hungry. It's more data hungry. It's more compute hungry, and it's a bit more of a specialized skill set. So it's like maybe more expensive to get started, but then once you have a model up and running, it can be more standardized. And then I think what's really interesting is that there's a third paradigm emerging for building machine learning applications, which you can think of as like machine learning 3.0. And what this is like building machine learning powered products on top of foundation models, on top of large language models like GPT-3, ChatGPT, and equivalents from in the open source or from other companies. And I think it's a lot of people who haven't built with this technology yet don't realize how different it is from that machine learning 2.0 toolkit and skill set. And the big difference is that you can get really far in this like 3.0 paradigm without needing to train models at all. These models have become capable enough that just by engineering the context of what you send to the model, the prompt of what you send to the model, you can usually get to a prototype that works pretty well, without needing more than like maybe a handful of data points. And that doesn't mean that you won't eventually need to train the model or eventually need to put a lot of engineering work into making the model work well if you wanted to solve all of the problems that you want to solve. But the difference between needing to have like a data set and a training infrastructure set up and all of the work that goes into being ready to even run a deep learning experiment, the difference between that and being able to just fire off an API call and hack around with a prompt is like, I think, multiple orders of magnitude improvement in the speed of getting to an MVP. And that I think is a pretty profound implication for how companies are building applications with this like 3.0 stack.
And for teams who are using this large language model or foundation model approach, as you said, it's definitely a lot faster to get started. It's a lot faster to get to something that is functional. But I'm curious what you see as some of the risk factors in evaluating which model do you build your foundation, or do you use as your foundation? What are some of the potential customizations that you might need to do? How do you identify whether or not you're going to be able to get all the way to your desired end state with that foundation versus having to get, halfway there or three-quarters of the way there and then having to go all the way back to the beginning to actually build your own custom model because it doesn't quite have all the right kind of source information or source parameters that you need to be able to get to your kind of final desired end state?
I think there's like the two biggest risk factors that I see are like a platform risk and a technology risk. The platform risk is that if you are building on top of these foundation model providers, if you're building on top of OpenAI, Cohere, really any of these providers, these platforms introduce constraints. They have outages. They have latency requirements that you can't really work around, and the access that they give you to the models themselves is somewhat limited. You can do a lot of things with them, but you can't do everything with them. And so that introduces the risk that at some point down the line you're going to realize, hey, this the offering from this provider is not flexible enough for me to really do the exact thing that I want to do, and so I need to go backward. I think that's a risk, but I think the bigger risk is the like underlying technology risk, which is that these systems, these large language model based systems, are incredibly capable and very easy to get started with relative to other machine learning systems, but they're not silver bullets. They have very real and very pronounced failure modes, as we've all seen at this point with Bing and Sydney and things like that. And getting from an MVP to an actual real reliable working product that runs in production and consistently produces the output that you feel comfortable putting in front of your users is very difficult. And that is at this point an inherent limitation of the technology. It's overcomable, but it's I think like the biggest failure mode that I see with companies applying these technologies right now is you can get to something that works 80 or 90% of the time extremely quickly, which produces a lot of confidence that like, hey, we can, we've got a product here, we can ship this thing. But then getting from that like 80 or 90% level to something that's as reliable as you'd want is often the hardest part.
And for teams who are either new to machine learning or maybe they've been doing it for a while, I'm curious what you see as some of the variance in terms of the necessary skills and internal capabilities and tooling and some of the types of investment that they need to be thinking about making to bring themselves into this modern era of model building and validation and operation.
Yeah. I think the interesting thing about this like 3.0 foundational model stack is that you really don't need traditional machine learning skills to get started. A lot of the companies that I see building with this, they went out and tried to hire someone who had experience with this skill set and couldn't find anyone because it's brand new. And so they just had their engineering teams try to get started and were able to figure things out pretty quickly. So that's, I think, one of the big differences. In the old world for deep learning, you kind of do need people who are pretty specialized in understanding the technology more or less right away, in order to have a high likelihood of success for your projects. But I think that the risk there, the thing that a lot of these companies miss is that just because this is a new and easier way of building machine learning applications doesn't mean that the fundamentals of machine learning don't apply. And in particular, I think a lot of companies that are that are starting now and are building things with this new stack are underestimating the value of a lot of what the previous two generations of machine learning teams realized a long time ago, which is reproducibility, evaluation, and the ability to iterate quickly using the feedback that you're getting on your model's predictions from your end users in production. And so I think that a lot of the companies that are that don't have experience in earlier paradigms of machine learning that are adopting a foundation model based stack now are going to reinvent the wheel and like find their way full circle back to a lot of the production ML and ML ops practices that experienced ML practitioners are already familiar with.
And Another piece of this that I'm curious about is for teams who don't have that existing expertise in machine learning. What are some of the kind of initial pieces of education that they need to consider around how to even determine which foundation model is going to give them the capabilities that they want, or if it's really just a matter of try it out and see what works and just iterate until you find something that sticks?
Yeah, it's pretty easy to try it out and see if it works these days. I think that there is a bit of a skill set around getting these models to like getting quickly to figure out the limitations of the capabilities of any of these models. And that skill set is not really very well codified today. A lot of people who learn how to do this learn by reading the dark corners of Twitter and Reddit and finding the toolkit of tips and tricks in the deep recesses of the internet. We're actually teaching a class. I help organize a machine learning education series called Full Stack Deep Learning, which started off as kind of like the first MLOps class, or at least the first MLOps class that was focused on deep learning. And we are teaching a new class coming up here in a couple of months on building with the foundation model stack. And so hopefully we'll produce some materials there that will be kind of that like 101 or 201 level material that you need in order to get to your first MVP or your first product.
And so for teams who are just saying, we want to be able to use machine learning for X, I'm curious what your typical first recommendation is now, and whether you view kind of modeling as a discipline as being something that is on the way out, or is it one of those things that is evergreen, but it's just going to be an increasingly specialized role, similar to something like a database administrator in the era of the cloud?
Yeah. As sad as this is for me to say, as someone who is trained, in how to be, I spent a lot of time building machine learning models from scratch. I think that the skill set of training machine learning models is never going to go anywhere, but it's becoming an increasingly smaller part of the pie. And I think the way that most companies are going to consume machine learning is not by, not by hiring people who are experts in the modeling side of the house. It's by, consuming a higher level abstraction that uses machine learning under the hood and like does the optimization process for them under the hood. And what they're going to be specialized in is applying machine learning, not at the algorithmic level, but at the process level and at the data and data analytics level to the specific business problems that they're being tasked with. So I think the role of modeling in most companies building products with ML is rapidly diminishing, but machine learning as a whole is also rapidly growing in importance. So maybe now is not the best time to get into machine learning modeling, but I think there will always be a role for people who know how to build models.
Over the past decade or so, there has been a lot of investment put into all of the tooling and education and resources around how to manage that modeling life cycle of how do you get the data into a state where it's clean, how do you develop the model initially, what are some of the algorithmic concepts that you need to be aware of, how do you manage the experimentation flow and figuring out kind of what are the optimal parameters, hyperparameter tuning. And so now that we've built up to this level where we can say, actually, you don't need to worry about any of that. Most of that's already done. You just take this model and then tweak the bits that you care about. Now that we are at that point, what are the kind of next steps? What are the resources that teams do need when they say, I don't need to be an expert in modeling. I just need to know which model does the thing that I want. But there's still a lot that goes on and around actually operationalizing those models, managing them, figuring out how to identify when they are in some sort of failure mode. And I'm curious what those additional capabilities are and the areas of expertise that teams need to be investing in to be able to consume those models and use them as an operational part of their products.
Well, a couple of things I want to say here. First, just like you don't need to go study operating systems or database systems in order to get a job and be an effective software engineer today. But if your goal was to be the best possible software engineer, it'd still probably be worth studying those things, because understanding the fundamentals is still often very helpful, even if you're working at a higher level of abstraction. I think the same is true with ML. So if even if you don't expect to be needing to spend all of your time, fuddling with model architectures and tuning hyperparameters and things like that, understanding those things at a deep level will help you when the abstractions that you're using fail you. So I do still think there's value in learning the fundamentals of training models. And the other thing I'll say is that this is all changing very quickly. So I think if I were running a machine learning team today, or running a company that was looking to adopt machine learning today, I don't know that I would make the bet that we don't need to hire ML specialists, because I think this is being able to build ML with no machine learning specialists is just starting to be it's like at the edge of the possible. And so I think a much more reliable path would still be to go hire people who know how to do the modeling piece, as because there might be pieces that you need to figure out. There probably will be pieces that you need to figure out that have not been baked into these abstractions yet. That being said, I think I don't think that there is a single place that you can go today to learn how to apply machine learning without, from the perspective of a practitioner who is not going to be a machine learning expert. But hopefully, this like new full stack deep learning LLM class will be a helpful starting point for folks.
And so, in terms of what you're building at Gantry, I'm curious if you can talk through some of the capabilities that you're providing and what you see as being the support structure that is necessary and useful for teams to be able to actually incorporate these models into their systems and be confident that they are doing what they want them to do.
So let me start with like a bit of a longer term view. So we've been talking about this idea that, hey, in the future, a lot of teams that are tasked with building products with machine learning might not need to actually understand the modeling piece of machine learning at the level that they do today, or that they did 2 or 3 years ago. And so in that future world, we can ask ourselves the question, what are those teams going to be doing? Like, what is the main activity that's going to go into building production machine learning systems, if not training models? And I think the irreducible complexity in building applications of machine learning is actually taking a model, which models themselves are not products. Models are algorithms that can make predictions on input data, and figuring out how to apply that model to the business context, the actual problem that you as an organization need to solve. So what does that look like? It looks like understanding the data really well, understanding the problem really well, and also understanding how the model maps onto the data and to the problem. Where is the model performing well? Where is it not performing well? Where do we trust it? Where don't we trust it? And what does the roadmap look like for us to make this model more reliable or perform better for the critical use cases that we have for it? Not just like general performance, but actually task specific performance. And so that work, to me, looks less like being a machine learning researcher today, and more like being like a traditional data analyst, or someone, or in some ways even like overlapping with a product manager, where your goal is like to understand the current state and help guide development towards something that looks better. So in the longer term, if that's the way that organizations are building machine learning applications, then Gantry is the tool that these folks are going to use to actually do this process of taking a generic model that works pretty well and adapting it over time to be more and more task specific. What does that look like? It looks like, well, first you need to be able to actually understand whether the model is doing what it's supposed to be doing, and what its failure modes are, and what are the opportunities to make it better. So the first part of our product offering is sort of an analytics suite that helps you to understand model performance, diagnose failures, and find opportunities to make your model better. And then the second thing that you need to be able to do is not just detect problems, right? Because if you figure out a problem with your machine learning system but you can't fix it, that's not very useful. So you also need to be able to actually use those insights that you get from looking at how your model performs in production, and use that to make your model better over time. And so that involves basically folding your training data back into your production model, and retraining your model to evolve it over time to adapt to the needs of your product context or your end users. And so that's essentially what our product is designed to do. And in the shorter term, the users of this product are not like necessarily the folks that are non-machine learning experts who are just tasked with like taking an off-the-shelf model and adapting it. Our product is really useful for machine learning experts and machine learning teams as well to perform that same function of effectively taking what we know, like how what we know about the problem that we're trying to solve, and then adapting our model over time to solve that problem better. So the benefit that companies tend to see from this is models that perform better for less cost, because you have to put less manual work into actually getting them to that level of performance, and a reduced cost of maintenance, because oftentimes it's easier today than ever to get models into production, but keeping them there is oftentimes what ends up being more difficult.
And in terms of your product management, product design, I'm curious what you've encountered as some of the unique challenges of building a platform and tool chain focused on supporting machine learning use cases, but with the anticipation that a lot of the people who are using it aren't necessarily going to be machine learning experts in their own right, and being able to surface useful information and guide them in the proper direction to be able to understand the kind of scope and ramifications of the errors that they're experiencing and help to direct them along the path of finding and implementing a resolution for those problems.
Yeah, and today, even though today it is mostly machine learning experts, or at least like very machine learning familiar folks that use our platform and do this job in most companies, we're definitely building towards a future where not everyone working on this process in companies needs to be machine learning experts. And so the main way that we try to do that is by abstracting away a lot of the sort of things that are specific to models in our platform. And so oftentimes our platform, feels more like using a data analytics platform, where the thing that you really need to be able to understand is the data that's going into the model and the sort of outcome that you're aiming for. And then we help you like find subsets of data or find subsets of users on which the model is not doing what it's supposed to be doing, and then make it really easy to fold those insights into training without necessarily needing to be the one who is like designing the model architecture or writing the training loop yourself.
And in terms of the implementation, I'm wondering if you can talk through some of the kind of engineering that has gone into building Gantry and some of the process for teams to incorporate it into their systems and workflow so that they can take advantage of the services that you're providing.
Yeah, for sure. Under the surface of building something that is designed to be simple to adopt and feel simple to use, there is a lot of like really complex data engineering and data infrastructure work that goes into that. In particular, we need to be able to ingest large streams of data in near real time. We have customers who send us hundreds of millions or bordering on billions of records per day. We need to be able to process all of that data efficiently. We need to be able to handle delayed feedback. So oftentimes in machine learning, you have a model that takes an input from a user, it makes a prediction, and then at some point in the future, you get feedback on whether that was the correct prediction or not. Maybe it's not too long in the future, like a few seconds after you make the prediction, the user gives you implicit feedback by clicking on your recommendation or not clicking on your recommendation. But in other cases, that feedback happens long in the future, weeks or sometimes even months later, like in the case of fraud detection, where you might find out if there was a chargeback on the prediction that this transaction was fraudulent, weeks after the prediction was made. So the second, like really big sort of data infrastructure technical challenge is how do we join these massive streams of data together and compute metrics on the fly, even when we don't know when the feedback is going to occur. Then, a third big challenge is, like you have all of this like massive amount of data that's coming in. Some of that data is tabular data, but it's often also unstructured data. It's images, it's text, it's things of that nature. And we need to be able to allow users to query that data rapidly in real time to be able to analyze, hey, we saw this like new failure mode occur all of a sudden. What's the cause of that? Like what subset of our data is driving that? What user group is driving that? And so the query side of it is a big challenge as well. And then lastly, there's just a ton of complexity in the machine learning workflow. So You have model training, which is often done by different people than the people who deploy the model. When you deploy models, you have to keep track of the data set that those models are trained on. You have to understand like when the models were deployed, when you're rolling out a new version. And so there's a really difficult sort of metadata management challenge as well, which involves like basically gathering metadata from all these different, often disparate parts of the system, putting it all into one place so that the people that need to be able to manage this workflow have access to it and can also start to build automations and like orchestrations on top of it. So those are some of the big technical challenges that we're wrangling with. Not to mention things on the algorithmic side like active learning, drift detection, borderline research questions as well.
And one of the trends that I've been seeing as I talk to folks who are working in the machine learning and particular ML operations and some of the kind of supporting infrastructure space is the risk of starting with a particular problem that you're trying to solve and then ending up branching into all of the other adjacent problems because it's still a very young space. And so it's not always clear kind of what are the appropriate boundaries for a given product category. And I'm curious, as you've been going through this process, what are some of the kind of clear boundaries that you're setting for yourself to avoid some of that tendency to sprawl into neighboring capabilities and some of the pieces that you are consciously not trying to target because of the need to be able to stay focused and deliver on the core problem that you're trying to solve?
Yeah, so we are entirely focused on the problem of what happens to models after you deploy the first model, right? So our thesis is that modeling is no longer the hard part for most companies. As a data science team, you probably have figured out already how to build the machine learning model that solves your problem offline in the abstract on a fixed data set with a fixed metric. Our goal is to help you, once you've deployed that model, help you maintain it, and ideally help you improve it over time by using signals from production like outcome data or user feedback data. And so, we help with like continual learning, active learning, model maintenance, model retraining, reinforcement learning from human feedback, problems like that, where you really only start to face them after the first model is deployed. And so the parts of the workflow that we don't touch are the experimentation workflow. So how do you build your first data set? How do you get it that data cleaned? How do you figure out what model works the best on that data set? How do you keep track of all those experiments? And how do you deploy that initial model into production? And I think there's a relatively clean break there, but there's also some overlap, right? Because for example, when you're doing continual learning, you need to be able to retrain models. Our assumption is that our users are going to tell us how to retrain the models. And we're just going to be like relative to that, we're just going to be an orchestrator and a data provider. But that distinction, is mostly pretty clean, but that's sort of where we start to get into some overlap with the training side of the house.
Yeah, and particularly as you get into some of the more specialized approaches to modeling, I'm curious to what you are focusing on as the core capability that you want to support, thinking in terms of things like, batch versus continual training, federated versus centralized learning, things like that.
Yeah, we, for better or for worse, mostly for better, we have not made a lot of assumptions in our platform about what is the type of machine learning that you're doing. So we have customers doing everything from audio processing to computer vision to traditional ML use cases, recommender systems, search, but I would say like probably the most common use case for our platform right now is NLP, and I think there's a few reasons for that, but that's I think like the most common thing that people are using us for. So we really don't make a lot of assumptions about what type of ML you're doing. And we've designed our platform in such a way that it can support a lot of different use cases. The big advantage of that is for a lot of teams, especially teams in larger companies, you probably have a lot of different types of machine learning problems that you need to support. For example, you might have some document digitization problems, some internal knowledge management, NLP or search problems, as well as some like analytics, ML, or recommendation system problems. And so being able to have one system that supports all of those use cases, we found is super valuable for teams as they try to scale up to, maintaining a larger number of production applications without necessarily ballooning the size of their team.
And as you have been building the system and working with some of your customers and keeping track of what's happening in the broader environment, what are some of the most interesting or innovative or unexpected ways that you've seen teams approach this challenge of building their models, deploying their models, and making sure that they're generating appropriate feedback to figure out what direction to push their efforts?
Hmm. Um, yeah, it's tough. I mean, nothing surprises me anymore. So, yeah, I mean, I guess one thing is interesting. That's interesting is I've started to see a lot of teams become really scrappy on the infrastructure side. So, for example, like there a lot of companies that we talk to try to just do as much of their workload in their data warehouse as they can. They, maybe rather than like going out and building or buying a feature store, they just use DBT models to define feature transformations and then dump the output of those into Redis. And that turns out to be good enough for them to start out with. And yeah, so I think like the thing I'm often impressed with is just the scrappiness of machine learning teams who often have, really should have like 10 different roles, but it's, a small and lean team that's sort of forced to do all of the different components of the job.
Absolutely. And in terms of your experience of building Gantry, I'm wondering what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think I'm a machine learning researcher by training, right? Not a software engineer, not a product manager, and so I think I think I knew this was going to be going hard going in, but I have gained a new admiration and respect for people who build really great, like delightful products. Because if you've never tried to do something like this before, I think the amount of work that and thoughtfulness that goes into making all of the little decisions that you take for granted when you're using a great developer tool or a great product of any kind, there's just it's enormous in scale and magnitude. And so it's been humbling to learn how to do that, hopefully learn how to do that well. And it's definitely given me a lot of respect for some of the products that we use on a day-to-day basis.
And so, for teams who are in the process of getting their models into production and figuring out an appropriate workflow to be able to continue to evolve and evaluate and improve their models, what are the cases where Gantry is the wrong choice?
Yeah, I think Gantry is the wrong choice if you're doing machine learning more in this analytics driven paradigm. If you have models that are going to be used as part of a decision making process that don't need to be refreshed very often, I just don't think you really need something as complex as Gantry to monitor and maintain those models, because you already have humans that are sort of evaluating the quality of those models as you go. But I think anytime, especially that you have models that are going to be interacting with end users, and where your predictions are going to be in any way part of your product, whether that's like your actual customer facing product or whether that's a product that you're going to be using internally to make things more efficient. My strong recommendation is to deploy Gantry or a system like it as part of the first deployment that you do, because there's just so much benefit. Like most of the gains that you'll see in model performance and more importantly, like downstream task performance, will come after you deploy the initial MVP model if you're doing things right. And so I think having the right tooling set up for that and being able to do that process more efficiently is incredibly valuable.
And for people who are interested in staying apprised of the so-called state of the art or best practices around model development, model maintenance, what are some of the resources that you have found most helpful to be able to stay up to date, particularly since this is a very nascent and constantly moving space?
Yeah, I get most of my what I've found to be the most helpful, honestly, is just social media, following people who I respect on Twitter and LinkedIn. I do my best to try to aggregate some of the things that I'm reading as part of our newsletter, and then we also teach classes on this through Full Stack Deep Learning. So the previous Full Stack Deep Learning that's focused on more traditional model development and how to do that effectively is all available for free online. And if you're interested in learning how to do more of this like ML, 3.0 paradigm, this like large foundation model based approach to building AI applications, then would encourage you to check out our upcoming bootcamp in April.
Are there any other aspects of this space of modeling as a practice and the ways that it's evolving, or the work that you're doing at Gantry to support that we didn't discuss yet that you'd like to cover before we close out the show?
I think that covered it pretty well.
Okay. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And
Sounds
as a
good.
final question, I'd like to get your perspective on what you see as being the biggest barrier to adoption for machine learning today.
I think the biggest barrier for adoption to machine learning today is going from a prototype to something that you can trust and that you can rely on to work well and consistently for your end users in production. I think it's never been easier than now to get started and to build something that makes a really cool demo or a really cool proof of concept, and where you can start to see the promise of the technology. And that's great because that's opening a lot of people's eyes to how much these technologies can improve your product experience. But the hard part for most companies today is how do you go from that to something that that you can rely on and that you feel comfortable with your customers interacting with on a day-to-day basis.
Awesome. Well, thank you very much for taking the time today to join me and share the work that you're doing at Gantry and your perspective on the necessary skills and capabilities and areas of focus for machine learning model development and deployment. Appreciate all the time and energy that you and your team are putting into that, and I hope you enjoy the rest of your day.
Thank you. I enjoyed it, and I hope you enjoy the rest of your day as well.
Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and Podcast.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.